welcome to solving linear equations. So in the topic of algebra, which is in paper number 1. So guys, where I'm going to get you to pop as far as page number 43 in your notes. On page number 43, you'll see your heading there, solving linear equations. Now to start off, what is a linear equation? Well, a linear equation, as you'll see up here, is an equation first of all, because it contains an equals to sign. Once you have an equation, what we know is that it can be solved. Now, the reason we say it's linear is because our variable in this case, which is x, is to the power of 1. If it was to the power of 2, we'd say it was quadratic, or 3, we'd say it was a cubic equation. So again, a linear equation only has one solution. Now, we're going to jump across the page, and I'm going to show you how to solve linear equations. Over on page number 45, exercise 6.1. We're asked to solve each of the following, and what I've done is I've taken a selection of these questions. Starting off kind of nice and easy and just building our skills along the way. So start off part A. We're asked to solve 5x equals to 15. Now here this is kind of like me saying 5 chocolate bars are equal to €15. What's the value of 1 chocolate bar? X being your chocolate bar. We're trying to find the value for x. Now a lot of students will look at that and just go straight away, 3. But how do they get to that conclusion? In this case here, this is 5 times x. 5 multiplied by x equals 15. What's the opposite to multiply? Well, the opposite to multiply is divide. So I'm going to divide the left-hand side by 5 because 5 into 5 goes once. If I do that to the left-hand side, I must do the same to the right-hand side. Divide it by 5. So on the left-hand side here, 5 into 5 goes once. And on the right-hand side, 5 into 3 goes, 5 into 15 goes 3 times. So here you're going to see that x is equal to 3. Now, what students should always do, just to be careful, is check their answer. Again, your calculator will help you do this. How will we check the answer above is correct? Well, we'll take our original linear equation, which in this case is 5x equals to 15. And what we'll do is we'll sub in the value for x, in this case, which is 3. Once we do that, one side should equal the other, or we should be able to cancel both sides out. So here, 5 times x is 3. Is equal to 15. 5 times 3 is 15, so 15 is equal to 15. And again, you could bring that 15 across and it would all cancel out. What that tells me there is that this answer is correct. Let's move on to part C. Now for part C, again, different set of skills here we're looking at. We'll see 3x minus 10 equals 2x minus 3. Now in this case here, what you'll notice is that there's variables. The variable x is either side of the equals sign. The same with your constants minus 10 and minus 3. Now what we want to do is reshuffle this, that everything with an x is on one side, I'm going to say left hand side, and everything that's just a number or constant is on the far side. Now when you were in first year, you would have probably approached it in this way. I'll do this once and I won't show this again. You'd have probably said to yourself, well, I have 3x minus 10 is equal to 2x minus 3. You'd have probably said to yourself, I'll just space this out ever so slightly more, said to yourself, right, I only want everything with an x on the left-hand side. So I want to get rid of minus 10. Now, what's the opposite to minus 10? The opposite to minus 10 is to plus 10. And on the far side over here, you'd have probably said to yourself, well, I only want numbers over here. So here, I have 2x. The opposite to 2x is minus 2x. Now, you'd have probably started off by doing that. But what you'll know yourself is that what you see in the red, if you add 10 to the left-hand side of that equals to side, you have to do the same to the far side. If you subtract minus 2 over here, you must subtract, and I'm just going to come over here, minus 2x over here. It's a balancing act, not my neatest work. Now, that is usually how first years will deal with this. They'll say to themselves, plus 10, minus 10 cancel, 2x minus 2x. And it's the same as saying, get everything with an x to the left-hand side, i.e. take this 2x and bring it across. Here you're going to be left with 3x, bring that 2x across, change its sign, that will be minus 2x. And on the far side here, you have minus 3 already. What you can do is take your minus 10 and again, bring it across that equals to sign and change its sign. You're going to have plus 10. Now that ends up as the exact same as 3x minus 2x. and minus 3 plus 10. Bring it across your equals to sign, change its sign. It's just a different way of viewing it, but it's the same method. 3x minus 2x is going to leave me with 1x or x, and minus 3 plus 10 is going to leave me with 7. So 1x, or alternatively, if you just want to say x, either, is equal to 7. Now again, you can take a couple of moments to yourself, pause this video, and check your answer by subbing it in to the original. We're going to move on as far as part E. Now for part E, you're moving across the page, over as far as page number 46. And with part E, what you're going to notice here is you're going to notice that there's brackets involved. So what's our first job going to be? We want to solve for x, but the first thing we have to do here is actually remove them brackets. So let's start with that. We have 3 times x and 3 times minus 2 on the left hand side. 3 times x is going to leave me with 3x, and 3 times minus 2 is minus 6, is equal to. On the far side here, we have 7 times x and 7 times 5. Here, 7 times x is going to leave me with 7x, and 7 times 5 is going to leave me with plus 35. Bring down my minus 13. Now there my brackets is removed. Let's look at either side of that equals to and see can we add or subtract any like terms. On the left hand side here we have 3x minus 6, nothing can change there, can't add them together. But on the far side here we have 7x, and what you'll see is you have 35 minus 13. 35 minus 13, that's going to leave me with 22. Now, final steps. What we want to do now is bring everything with an x to one side and everything without to the far side. So similar to what we see on our previous question here, part C, we're bringing it across that equals to sign and changing the sign. That's kind of a quick, easy way of thinking it, but technically it is the long way. Now, I'm going to bring everything with an x as per usual to the left hand side, everything with a number to the far side. I do know you can do it the other way, and it's a little bit easier, but I just want to show you this way because generally speaking, this is what students will do. So anything with an x, I have 3x over here. I'm going to take my 7x and bring it across the equals to sign. On the left hand side here, I'll be left with 3x. Take this positive 7x, bring it across that equals to sign. It becomes minus 7x is equal to. Here we have 22. Take this minus 6, bring it across my equals to sign, and it's going to be plus 6. So we have 3x minus 7x is minus 4x, is equal to 22 plus 6 is going to leave me with 28. Now we don't want to know what minus 4x equals to, we want to know what positive 1x equals to. So this is minus 4 times x, and the opposite to multiply is divide. So we're going to divide by that number attached to the x, minus 4. We're going to do the same to the far side. Divide the right hand side by minus 4 also. Again, what you do to one side, you do to the other. On the left hand side, minus 4 goes into minus 4 once. And on the right hand side, minus 4 goes into 28 minus 7 times. I had to think for a second. Here, on the left hand side, x is equal to minus 7. Again, pause the video, take a second, and check your answer by subbing it into the original equation, even if it's just on the calculator. Now, the last question we're going to look at here is across the page one more time, and it's exercise 6.2 on page 47. Here we're asked to solve the linear equation, but this time what we see is our favourite, fractions. So we're asked to solve when there's fractions involved. Now, what do we do when we have fractions? Well, the first thing we always do is make everything a fraction. In order to get rid of the fractions, we want to get rid of the fractions. Nobody likes dealing with fractions. I'm very aware of that. We want to get rid of them. But before we do, we have to make everything a fraction. Here we have x minus 3 over 3 minus 2x minus 2 over 5 equals 3. Let's make this 3 a fraction. Let's place it over 1. 3 is the same as 3 over 1. So how are we going to get rid of them? Well, the easiest way is using your lowest common multiple. So I want you to look at your denominators, 3, 5, and 1. What will 3, 5, and 1 all divide into evenly? Your LCM. Well, they'll all divide into 15 evenly. So just like we did when we simplified, what we're going to do is we're going to multiply each of these fractions by 15. The only difference here is you don't have to divide by 15. When we were simplifying, we also divided the whole lot by 15. Now, once we multiply each of them by 15, so it's like the balancing act, you're doing the same thing to each one of these fractions, we're going to say to ourselves, 3 into 15 goes 5 times. 5 into 15 goes 3 times. And 1 into 15 goes 15 times. Let's see what we have now. We have 5 bracket x minus 3 minus 3 bracket 2x minus 2 equals to 15 times 3. We've got rid of the fractions. They're gone. And this is so much easier to deal with. It's actually very similar to what you see here behind me. So let's remove the brackets first. Step number 1, after getting rid of the fractions. We have 5 times x and 5 times minus 3. 5 times x is going to leave me with 5x, and 5 times minus 3 is minus 15. Next, we have minus 3 times 2x and minus 3 times minus 2. Minus 3 times 2x is going to give me minus 6x, minus 3 times minus 2, minus by a minus is a plus, 3 times 2 is 6. Finally here, we have 15 times 3. 15 times 3 is going to leave me with 45. Now, next step. Any like terms on the left or right hand side? Can we do a little bit of tidying up here? Well, on the left hand side here, you'll notice you have 5x and minus 6x. 5 minus 6 is going to leave me with minus 1x. But you also have minus 15 and plus 6. Minus 15 plus 6 is going to leave me with minus 9 is equal to 45. That's the left hand side tidied up. Let's keep our x's to one side, numbers to the other. Now, I like my x's to the left hand side. Not everybody's like me. Some people will move that across. Absolutely perfect if you do. I'm going to take this minus 9 and I'm going to bring it across my equals to sign. So I'm going to get this minus 1x left and so on. So minus 1x is equal to 45. Take this minus 9 across your equals to sign and it changes to plus 9. I'm left with minus 1x is equal to 45 plus 9 is going to leave me with 54. Now I wanted to leave my answer like this. Why would I want to leave my answer like this for a second? Is this the final answer? No, it's not. Because we cannot leave this as minus 1x. It has to be positive x, okay? Positive 1. So what am I going to do? Some people multiply both sides. Some people just change the signs. That's fine, okay? We all have different techniques. You are in 5th and 6th year, so you will have a technique you're already comfortable with. But if you haven't, this is what you do. How will I get rid of that minus 1? Well, I'll divide by minus 1. If I divide the left-hand side by minus 1, I divide the right-hand side by minus 1. Minus 1 goes into minus 1 once, and minus 1 goes into 54, minus 54 times. So here, what we're left with is x is equal to minus 54. Again, similar idea. Take your answer, pop it into your original equation, and one side should equal the other. Guys, that is solving your linear equations.